Hi everyone. So today is 14 July 2020 and from today exactly 136 days are remaining for CAT 2020 and I'm going to discuss three questions from numbers. The first question is from classification of numbers. The second question it is from the based on divisibility rule and the third question is based on the factors. So all these three concepts are important for CAT. So you can pause the video and try to solve these three questions. Okay, now let's start here. Question number 37. It says for how many positive integers n square minus 3n plus 2 is a prime number. So we know that n square minus 3n plus 2 and this number must be a prime number. So factorize n square minus 3n plus 2. I can say this is n square minus n minus 2n plus 2. Okay, and this is a prime number. So I can say n is common in the first two terms. So this is n into n minus 1. Then minus 2 into n minus 1. And if you simplify it further, it is n minus 2 into n minus 1. And it's a prime number. So basically we are writing this prime number as a product of two integers. N is integer, positive integer. So these are nothing but these are two integers here. So the question is, in how many ways I can write down the prime number as a product of two integers? But can the prime number be written as a product of two factors such that both the factors are greater than 1? No. Like if I say there is a prime number, for example 2. 2 can be only written as 1 into 2. The product of two number 1 into 2. Or maybe I can say minus 1 into minus 2 also. If I am counting the negative also. Similarly, if I take a factor 3. So 3 prime number, it can be only written as 1 into 3 or minus 1 into minus 3 and so on. And there is no other possibilities. So if it is a prime, so there are only two possibilities here. I'll say this number n minus 2, it is equal to 1. Okay, let's say this is a prime number p. And n minus 1 is equal to p. Or n minus 2, it is equal to p and n minus 1 equal to 1. Or n minus 2 is equal to minus 1 and n minus 1 is equal to p minus p. Or I can say n minus 2 is equal to minus p and n minus 1 is equal to plus 1. Sorry, minus 1. So these are the four possibilities. Now in the first case, let's see here. It says n minus 2 it is equal to 1 and n minus 1 is equal to p. And from the first value I'll get that is n is equal to t. And from here if I substitute n equal to 3, so I get 3 minus 1 which is equal to 2. And which is p. Is 2 a prime number? Yes. So the first case is definitely satisfying. And remember, n must be a positive integer. So here we are getting n as a positive integer only. Remember. So n equal to 3 is a positive integer. So at n equal to 3, this will satisfy. Okay, and what will be the value? We know this is n square minus 3n plus 2. So if I put n equal to 3, you can see that is 3 square minus 3 into 3 plus 2. So that is 3 square is 9. 9 minus 9 is 0. 0 plus 2 is 2 and 2 is a prime number. Okay. Now similarly in the second case, n minus 2 is equal to p, that is here, and we are getting n minus 1 is equal to 1. If n minus 1 is equal to 1, we'll get n is equal to 1. Now substitute this n equal to 1 here, and what will I get? The value of p? P is equal to 1 minus 2, which is minus 1. Is minus 1 a prime number? Remember, p is a prime number? No. So minus 1 is definitely not a prime number. So second case is not possible at all. Okay. So the first case is satisfying and second case is not satisfying. Let's take a third case. Here n minus 2 it is equal to minus 1 and n minus 1 it is equal to minus p. If n minus 2 equal to minus 1, so I'll get n is equal to nothing but that is 1. And substitute n equal to 1 here. So I'll get 1 minus 1 it is equal to minus p and p is equal to 0, which is not a prime. So you can neglect the third case also. Let's take the fourth case, minus p into minus 1. So fourth case, n minus 2, it is equal to minus p. Okay, and n minus 1, it is equal to minus 1. And from here, I'll get n minus 1 equal to minus 1, so I'll get n equal to 0. So I do not need to check because it says that n is a positive integer. So this case is also ruled out. Which means there is exactly one value which will satisfy this condition. And what is that value? that value is nothing but that is equal to 2. So the correct answer for this question is that there is n equal to 2. But the question is how many positive integers are there? So the answer is exactly 1. So there is exactly one positive integer for which this is a prime number. So I hope that this part is clear to all of you. Alright. Now let's move to the next question. Now another very interesting question which is based on the concept of divisibility rule. Similar question was asked in the CAT also, which was based on the divisibility rule of 9, and here it is based on divisibility rule of 11. Now it says let n be a 5-digit number and let q and r be the quotient and the remainder when n is divided by 100. Okay, so let me write down n. What is n? N is a 5-digit number, so I can say let me write down n is a 5-digit number. So it is equal to a, b, c, d, e. And whenever you divide any number by 100, what is the remainder? Remainder is always the last 2 digit. Okay, remainder is always the last 2 digit. For example, if I say 1, 2, 3, 4, 5. If I divide this number by 100, okay, what is the remainder? The remainder is equal to 45. And this is my remainder. And the quotient is simply 1, 2, 3. Alright, I can say this is equal to 100 into 1, 2, 3. And plus 45. So this is my quotient, this is my remainder. So similarly, I can say in this case, if I am dividing A, B, C, D, E by 100, what is the remainder? Remainder will be the last 2 digit and the quotient will be the first 3 digit. Alright, like if I say the number like 2, 5, 6, 7, 9. So this number is 256 into 100 plus 79. So if my divisor is 100, quotient is 256 and the remainder is 79. So I can say the value of Q, quotient, it is equal to ABC. And the remainder here, it is nothing but that is DE. Okay, and the question is for how many values of n Q plus R is divisible by 11. Alright, so Q plus R is divisible by 11. So let's see. So if I find out Q is a 3-digit number ABC, and if Q is a 3-digit number ABC, I can say this can be written as equal to 100A plus 10B and plus C. And DE, that is equal to nothing but that is 10D plus E. Now divide this number by 100. So I'll say what is Q plus R? So Q plus R, it is equal to nothing but that is 100A plus 10B plus C plus 10D and plus E. If I divide Q plus R by what? 11. I need to divide by 11. So if I divide 100 by 11, 11 nines are 99 plus 1. So the remainder will be 1 into A. Alright. Remainders are multiplicative in nature. 10. If I divide 10 by 11, so remainder is minus 1. 11 into 1 minus 1. So negative remainder of minus 1. 10 is 1 less than 11. So I can say 1 into A minus 1 into B. C divided by 11, remainder is C. 10 again, 10 into D. 10 divided by 11, the negative remainder is minus 1 into D and plus E. So it is basically, it is equal to what? That A minus B plus C minus D plus E. And it says that this is perfectly divisible by 11. That how many values of n is there such that it is divisible. So this is a multiple of 11. Multiple of 11. And can you guys tell me what is the divisibility rule of 11? Like if I say A, B, C, D, E. What is the divisibility rule of 11? How to check whether this number is divisible by 11 or not? What we do? We start from the right hand side and we say alternate, that is plus, minus, and plus. And if this sum, that is A minus B plus C minus D plus C, if this number is divisible by 11, it means the entire number is divisible by 11. And now compare this, all of you. Here what we have got, A minus C minus D plus C, and here also same thing. So basically I can say A minus B plus C minus D plus E. If it is a multiple of 11, it means what? That A, B, C, D, E is nothing but it is divisible by 11, as it is satisfying the divisibility rule of 11. So what does it mean? I simply need to count that how many 5-digit numbers are there which are divisible by 11. Okay, so now the things will become easy. Alright, so how many 5-digit numbers are there which are divisible by 11? So I'll say, let's say if I start with that is what? That is 11000. This is the smallest 5-digit number. 2, 9900 or 99,999. So I need to find out how many numbers in this range are divisible by 11. All the numbers which are divisible by 11, they will satisfy the condition that q plus r is a multiple of 11. So I'll divide this by 11. And I'll say 11. What is this comes out to be? 9. 11 nines are 99. Then I'll get 0, 1, 0. 9 ones are 11. Or I can say that will be comes out to be how much? This will be equal to 11 nines are 99. I'll get 1, 0. So again 910. Alright, or this will be, I can say this is 909. So I'll get this value as 909 point something. Okay. So 909 point something. Just a minute. Yes. So this is 909 point something. 2. This value. And this value, if I divide by 11, 11 nines are 99. Then I'll get put 0 and 11 nines are 99. And then I'll put again 0 point something. So I need to count all these numbers in this range. So the first number which is a multiple of 11, that is 11 into 910. 2, 11 into 9090. So how many numbers are there from 910 to 9090? So that is always equal to last term, that is 9090, minus first term, which is 910 plus 1. Okay, and this will be comes out to be 8181. And that is the answer. So basically, if you look at here, the question is simply they are asking how many 5-digit numbers are there which are divisible by 11. That's it. So I hope that this part is clear to all of you. Now let's move to the next question. So this question, again, it is based on what? Concept of factors here. Alright. So if it is based on the concept of factors, so how to solve this question? Let's see here. It says how many positive integers have exactly 3 proper divisors. So I've got 3 proper divisors. Means positive integral divisor excluding itself. So what is the total number of divisors, or I can say the total number of divisors here? Okay, so here the total number of divisors, there are 3 proper divisors and excluding the number. So if I include that number, so the total number of divisor is nothing but 3 plus 1, 4. So basically we are looking for a number in which the total number of divisors or factors is equal to 4. Now, so I can say if there is any prime number raised to power 3, what is the number of factors? In this case, number of factors, it is equal to nothing but that is equal to 3 plus 1, which is equal to 4 factors. Okay. And it says how many positive integers have exactly 3 positive, each of which is less than 50. Okay. So what are the factors of p cube? So the factors of p cube is 1 and p square and p cube. Okay, but the 3 proper divisor, these 3 factors, it must be less than 50. So I need to find out that p square is less than 50. So tell me p is a prime number. Remember, p is a prime number. So what all here? I can say that is 2 is satisfying, isn't it? And then prime number p can be equal to what? That will be equal to 2. Okay, and then I can say that is equal to 3 and 5 square 25 and 7 square 49. So 2, 3, 5, 7. So basically my number is 2 cube, 3 cube and 5 cube and 7 cube. So all this number has got exactly 4 factors. And excluding the number, remaining all the 3 factors are definitely less than 50. So these are 4 values. Now other possibilities. If my number comprises of 2 different prime numbers. So there is a one prime number which is p and the other prime number is q. So what is the number of factors? As the power of both the prime numbers will be 1 and 1. So in that case, I'm saying that if my number comprises of 2 different prime numbers. So in that case, the power must be 1 and 1. Then only my number of factors. The number of factors, it will be equal to 1 plus 1 into 1 plus 1. That is equal to 4. Okay, 2 into 2, 4. So in that case, these are two prime numbers. And what are the factors of here? The first factor will be 1, another factor will be p, another factor will be q, and the last factor is p into q. But these three factor, it must be less than 50. As the question says that each of which is less than 50, all the proper divisors, excluding the number means, are less than 50. So basically, we are looking for a prime numbers which are less than 50. There are two prime numbers. So here, so basically, we are looking for the numbers which are a product of two prime numbers, such that both the prime numbers are less than 50. So let me write down how many prime numbers are there which are less than 50? There are 15. If you do not know, you should know that there are 15 prime numbers in the range 1 to 50, and there are 25 prime numbers in the range 1 to 100. So what are those 15? I can write it down here. That is 2, 3, 5, 7, 11, 13. Alright, that is 17, 19, 23, 29, 31, 37, 41, and 43. So these are 15 prime numbers. So if you pick any two prime numbers, like the combinations can be product of two prime numbers. So 2 into 3, then 2 into 5. So how many combinations we can make? So out of 15 numbers, I need to select only two prime numbers to write down p into q. So out of 15 numbers, two of the prime numbers can be selected in how many ways? 15c2. And 15c2, it is equal to 15 factorial upon 2 factorial into 13 factorial, which will be equal to 105. So we have got 105 values here. Okay. So again, there are two different possibilities. The number can be either in the form of PQ, alright. So in that case, there are four possible values, or the number can be in the form of P into Q, where both of them are prime numbers. In that case, 105. So what is the answer? The answer is 105 plus 4. So 105 plus 4, it is equal to 109. Okay. So I hope that this is clear to all of you. So that's all for today. Thank you.